Assalamualaikum and a very good day. My name is Siti Nohidayah binti Mat Hashim and my matrix number are B0221101173 and my group member are Alif Harunuddin, Lu Hian Chuan, Sarah Nabila and Nurul Izzat Idayu. Our title for the group assignment is Bicycle Electric Generator. A bicycle electric generator is a project to create a simple human-powered generator from a bicycle that can run small appliances such as light bulb, laptops and cell phones. Mechanical energy produced by cycling can be transformed into electrical energy by using dynamo or DC motor. For this project, we are using bicycle to generate electric to charge smartphones while cycling. The generator converts mechanical energy into electrical energy, which is then converts from direct current DC to alternating current EC by means a converter and an inverter, and use the light bulb or power a small appliances such as smartphones. The concept of Faraday's law, which is electromagnetic induction, have been used in this project. The principle of electric generator. The electric generator works on a principle of electromagnetic inductions. Electromagnetic induction is a process of conductor is put in a particular positions and magnetic field keeps verifying and a conductor. When a straight conductor moves in a magnetic field, then a current is indeed in the conductor. A rectangular coil is made to rotate rapidly in a magnetic field between the poles and the horse-hole type magnet. When the coil rotates, and it will cut the magnetic field lines because of which the current is produced in the coil. The magnetic field within a brush current is passed through a commutator and a brush attached to the rotor to create a DC motor or dynamo.
In this experiment, we apply Faraday's law. Faraday's law is a basic law of electromagnetism, predicting how a magnetic field will interact with an electric circuit to produce an electromotive force, a phenomenon known as electromagnetic induction. EMF is induced by rotating an electric conductor in a magnetic field, which creates a flow of charges. This is the formula. Induced voltage equal to the number of loops multiplied by the change in magnetic flux divided by change in times. We use Fleming's left-hand rule to give which directions the currents.
Hi, my name is Alif Harunuddin Ismail. Matric number is B0221100090.
Hi, my name is Lu Hian Chuan and my number matric is B0221101168.
So for the construction, first we saw down a few blocks to make it as a base for our components. It's stated that R, D and O, which is regulator, diode and out. So next is we glue the components onto the board. Then we also glue the plastic wheel to the brush DC motor. This is for it to act as the rotary. This is for the DC motor to act as a gear connection with the bicycle wheels. Then we do the soldering process, which we glued the component on the board just now. Then we drill some holes on the motor block and we tie it with the cable tie to make it secure. This is to prevent it from moving around, which will disturb the system. In this clip, I apply a few cable ties between the DC motor and the wooden board for it to stay still. And this is the result of the distribution board and also the motor board. So this is a comparison between an unregulated DC voltage output and regulated DC voltage output. So in this clip, I didn't use any voltage regulator which outputs the average voltage of 7 volts. So in this next clip, I use voltage regulator LM7805 which outputs 5 voltage output, and it shows an average of 4.4 volts. So the output voltage is suitable for normal USB load which needs 5 volt output and 1 ampere.
Hi, so now I'm going to explain about the working principle. First, you can see here, come a little closer. This is the power generating board. So as the wheel rotates, the DC motor with the wheel here also rotates and produce power. So I tied a bunch of cable tie here to secure its position so it will not move during the rotation of the tire. As the wheel turns, it will produce power, voltage, and supply it to the LM7805. The LM will limit the voltage maximum up to 5 volts. The 5 volts sends it to the diode. The diode is to prevent any reverse current, prevent the load from burning. Then from the diode, USB port. Then the USB port, you can either put any load such as phone charger, or in this case we use USB box, LED box. So it depends on your type of load. So that's pretty much it for the working principle of this electric generator. Thank you. I am going to demonstrate our project. For the printing experience, I will turn off the light so that you can see the lines clearly. Okay, right now I'm going to show you how we want to charge this power bank using our electric generator. So the percentage level you can see is 0%, and I will insert this USB cable to the USB port. Put in the power bank in the safe place. And we can see the result after a few minutes.
Now I'm going to test run.
So as you can see, after 5 minutes ride, the percentage is increased to the 2%. For the further improvement of our project, we can add on some IC to make the voltage output more stabilized. It is to prevent the battery from damaging. And second one is the gear system over here. We are using the tire from the bicycle, and
tire from the DC motor. Because of the frictional between this tire, it make the tire at the DC motor become bald, and maybe we can improve the quality of the tire at the DC motor. And the last one is we can improve the power distribution board. We can add housing or casing over here to prevent it from the water damaging. Also external forces that we might not know from outside. Okay, that's all from us. Thank you.
In conclusion, we are able to help the environment by providing an alternative to charging portable electronics. This prototype for this system will provide one method for achieving this goal. With this device, cyclists may charge up their portable electronic while enjoying cycling.